What if the first definitive proof of alien technology wasn't a grand arrival, but, just a single ambiguous frame of data on a NASA live feed, visible for only a fraction of a second before the screen went black? This is the story of a hypothetical event, a thought experiment grounded in real science. On June 18th, a NASA feed tracking a fictional interstellar visitor named 3I Atlas suddenly cuts out. But not before revealing something that looks eerily artificial. Was it a simple glitch, or maybe our first glimpse of something engineered? Let's explore this together. The initial discovery. So, how does a story like this even begin? Well, it starts with the silent, relentless work of a real program, the Asteroid Terrestrial Impact Last Alert System, or ATLAS. Funded by NASA and operated by the University of Hawaii, this network of robotic telescopes with key figures like principal investigator Larry Deneau at the helm, scans the entire visible sky every 24 hours. Its primary mission is planetary defense, but its wide, fast survey is perfect for catching interstellar interlopers. In our scenario, on July 1, 2025, ATLAS flags an object on a hyperbolic trajectory. This isn't just another rock orbiting our sun. Its path proves it's a visitor from another star system, moving way too fast to be captured by our sun's gravity. After its trajectory is confirmed by the Minor Planet Center, it's designated 3Y Atlas. This would immediately trigger a global astronomical response. Scientists like Karen Meach, who led the characterization team for Oumuamua, would spearhead campaigns to observe the object with every major telescope available. This isn't just about getting a picture, it's a frantic race against time to gather data on a messenger from a distant, unknown solar system before it disappears back into the void forever. The anomalous frame. Here's the moment a routine observation becomes honestly a profound mystery. A public live feed is tracking 3I Atlas. At precisely 0317 and 12 seconds UTC, the feed freezes on a final frame before cutting to black. The image is mostly standard deep space fare, a dim, fuzzy nucleus surrounded by a cloud of gas and dust. But in the lower left quadrant, something is different. There is a razor-sharp glint of reflected sunlight forming a perfectly straight line. This is the kind of anomaly that would make a SETI pioneer like Jill Tarter take notice. Natural objects in space, comets, asteroids, dust clouds, are chaotic and irregular. Light scatters off them in diffuse, uneven patterns. But this glint is geometric. It behaves as if it's reflecting off a polished, flat surface. Independent astronomers running their own analysis software would see their edge detection algorithms flag the segment immediately. It's too consistent, too crisp. In the long search for extraterrestrial intelligence, this is exactly the type of techno-signature researchers look for, an artifact that appears manufactured, standing out starkly against the random backdrop of nature. The question is no longer just what is this comet made of, but was a part of it made at all? Data verification. An image this provocative is, well, worthless if it can't be authenticated. This is where the modern, decentralized nature of science communication becomes critical. In the minutes after the blackout, a global network of independent archivists and citizen scientists would swing into action. They run automated scripts that continuously record public NASA feeds. Packet captures of the 3I Atlas feed from servers in Germany, Australia, and the United States would be uploaded to multiple repositories. Each file, time-stamped 0317 and 12 seconds UTC, is protected by a unique cryptographic hash, a long string of characters serving as a digital fingerprint. This concept, with roots in the work of cryptographers like David Chaum, ensures data integrity. When compared, every single archived file matches, bit for bit. The German hash is identical to the Australian hash, which is identical to the original broadcast. This provides undeniable proof that the frame was not altered, manipulated, or a hoax created after the fact. The chain of custody is forensically sound, the evidence is clean. The anomaly, whatever its cause, was genuinely present in the data stream from the spacecraft. This eliminates any possibility of a simple prank and honestly forces the scientific community to confront the data as it is. Technical explanations. Before we entertain alien explanations, we have to exhaust all the mundane ones. So, why did the feed drop? The most probable official reason would be a routine network handover. NASA's deep space communications are a marvel of engineering, managed by experts like those at the Jet Propulsion Laboratory, but they aren't flawless. Signals travel from a spacecraft to a relay satellite in the Tracking and Data Relay Satellite System, or TDRS, then down to one of the 3 deep space network complexes on Earth. As the Earth rotates and satellites move, the signal must be handed off from one station or satellite to another. An engineer like Mark Raymond, known for his work on missions like Dawn, would explain that these handovers can occasionally cause a brief loss of signal. These handover blanks are common, logged, and typically last for a few seconds. They show up as a gap in the data logs with a specific reason code, so a blackout is not in itself a conspiracy. The entire system is built with these brief interruptions in mind. The deeply unsettling part of this scenario isn't the blackout itself, but its timing. A routine technical glitch occurring at the exact nanosecond a potentially paradigm-shifting anomaly appears on screen is a coincidence of astronomical proportions. Digital forensics. Let's put the frame itself under the microscope. Digital forensics is an unemotional discipline, and it offers 2 powerful non-exotic explanations for the straight edge. The first is video compression. To transmit massive amounts of data across millions of miles, images are compressed using algorithms like JPEG or MPEG. These codecs, whose development owes thanks to computer scientists like Ken Perlin for their work on procedural textures and noise, divide an image into an 8x8 pixel grid. When a faint linear feature happens to align with the grid's boundaries, the algorithm can snap it into a perfectly straight line, exaggerating its geometric appearance. It's an artifact of the math, not a feature of the object. The second culprit is a cosmic ray. Space is saturated with high-energy particles that constantly bombard camera sensors. A particle can streak across a sensor's pixels, leaving a bright, and often perfectly straight trail that lasts for only a single frame. This is a well-documented phenomenon. The most likely forensic conclusion would be a double hit. A cosmic ray created a faint streak that was then amplified and sharpened by the compression codec. It's an elegant, logical explanation that fits the evidence without rewriting any textbooks. But it can't entirely rule out that it was a real object that was simply processed by the same algorithms. 3I Atlas background. To grasp the full weight of this anomaly, we need to remember the real interstellar objects that preceded our fictional one. First came one Oumuamua in 2017. It was a complete enigma. Small, dark, and highly elongated, it showed no visible coma or outgassing, yet it accelerated away from the sun as if something were pushing it. This led Harvard astronomer Avi Loeb to famously propose it could be an artifact of extraterrestrial technology, like a solar sail. Then, in 2019 came 2I Borisov. It was a much more familiar sight, looking and behaving like a classic comet with a clear coma and tail, though its chemical composition was unlike anything from our solar system. These 2 real visitors set the stage perfectly. They proved that interstellar objects are a reality, and that they can be profoundly weird. Oumuamua, in particular, primed the scientific community to be on the lookout for anomalies. It opened the door to seriously considering technological origins. So, when 3I Atlas appears in our scenario with its own bizarre feature, it doesn't happen in a vacuum. It lands directly on the fertile ground of unresolved scientific debate and public fascination that Oumuamua left in its wake, making the stakes infinitely higher. Scientific scrutiny. In science, an extraordinary claim requires extraordinary evidence, a principle famously championed by the great astronomer Carl Sagan. A single ambiguous frame from one instrument is the very definition of not enough evidence. For the artificial edge hypothesis to be taken seriously, it would have to survive a brutal gauntlet of scientific scrutiny. First, the observation must be independently replicated. Different teams using different telescopes, like the Hubble Space Telescope or the Keck Observatory, would need to observe 3I Atlas and confirm the presence of the same geometric glint. Second, it needs to be a multi-wavelength detection. If the glint appears in visible light, does it also appear in infrared and ultraviolet? Spectral analysis of the glint itself would be crucial. If the light signature matched a known metallic alloy rather than silicate rock or water ice, the claim would gain significant credibility. As it stands in our scenario, the evidence is anecdotal. It sits on the lowest rung of the evidence ladder. Until multiple independent data streams confirm the same anomaly, the overwhelming majority of scientists would rightly remain deeply skeptical and favor a natural or instrumental explanation. The burden of proof is and must be incredibly high. 3 theories. After all the analysis, the scientific community and the public would be left grappling with 3 divergent paths. The first is the most conservative natural phenomena. A leading cometary expert, perhaps someone like Paul W. Chodas from NASA's Center for Near-Earth Object Studies, would argue that what we saw was a glint off a freshly exposed face of ice. Comets are dynamic bodies. As they heat up, jets of gas can erupt, putting immense stress on the nucleus and causing it to fracture. A large, flat piece of ice could easily shear off, and if it catches the sunlight at just the right angle, it would produce a sharp, geometric glint before tumbling away. The second path is the technical glitch theory, a perfect storm of a cosmic ray hitting the sensor in a straight line, which is then exaggerated by the video compression algorithm. It's an illusion born from the interplay of physics and software. But the third path, the one championed by thinkers like Avi Loeb, is the most profound. It posits that the object is not natural at all, that the edge is a real manufactured component of a larger object, a probe, a solar sail, or even a piece of interstellar debris from a civilization long gone. It is a long shot, but it remains a possibility that cannot be disproven with the available data. Broader implications. An event like this, even a fictional one, would transcend the world of astronomy and have profound societal implications. As Seth Shostak of the SETI Institute has often noted, the discovery of potential intelligence would change our perspective on everything. The immediate aftermath would be a firestorm of public debate about data transparency and potential cover-ups. Why did the feed cut out? Who made that decision? This would lead to intense pressure on government agencies like NASA to adopt even more radical open data policies, perhaps mandating decentralized real-time public archives for all raw telemetry. Funding priorities in science could shift overnight. Congress might allocate emergency funding to projects dedicated to the search for techno-signatures. The event also becomes a massive test of global media literacy. How does the public distinguish between credible scientific analysis and wild speculation? For a world watching, the line between healthy skepticism and unbridled wonder would blur, forcing a global conversation about our place in the cosmos and how we prepare for a discovery that could change humanity forever. One single frame could permanently alter how we look at the night sky. The search continues. While our story of 3I Atlas is a thought experiment, the real search it describes is entering a golden age. We are on the cusp of a revolution in astronomy with the imminent full operation of facilities like the Vera C. Rubin Observatory in Chile. With leading scientists like its director Zeljko Ivazic guiding the project, this observatory will conduct an unprecedented survey of the sky, discovering potentially dozens of new interstellar objects every year. This will transform the field from a data-starved science into a data-rich one. Each new visitor will be a data point, a clue from another solar system. Scientists are now actively developing the AI algorithms and observation strategies needed to characterize these objects quickly and efficiently. They are no longer just looking for comets and asteroids. They are actively hunting for anomalies. They are looking for strange light curves, unusual chemical compositions, and most importantly, objects that move in ways that defy our understanding of physics. The search is on, with more powerful tools and a more open mind than ever before. The next visitor is coming, and this time, we will be ready. The unresolved mystery of the 3I Atlas frame, though fictional, perfectly captures the tension between mundane explanation and profound possibility that drives science forward. It forces us to ask how we would react to a truly ambiguous signal from the cosmos, and highlights the absolute necessity of open data, rigorous skepticism, and relentless curiosity. What do you believe is the most compelling explanation for the anomaly and the blackout? Share your theory in the comments section below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the greatest mysteries of our universe. Thanks for watching Stellar Tech. Voyager 1, a tiny spacecraft the size of a car, is drifting through the unimaginable darkness of space, 14.5 billion miles from Earth. But nearly 50 years later, Voyager is still alive, defying the odds. Recently, this legendary probe has encountered something in the void that has scientists both amazed and deeply concerned. What has there found Voyager? The data streaming back suggests phenomena that challenge everything we thought we knew about interstellar space. Today, we explore Voyager's impossible encounter and what it means for humanity's future among the stars. The birth of a star sailor. The story of Voyager 1 began in the era of Cold War ambition, when NASA sought to expand humanity's horizons beyond Earth orbit. Under the leadership of Dr. Edward Stone, Voyager 1 was designed as a robust spacecraft capable of a grand tour of the outer planets, the first of its kind. Launched on September 5, 1977, from Cape Canaveral, it journeyed towards Jupiter with an array of scientific instruments, including the cosmic ray detector and plasma wave instrument. The spacecraft was engineered to survive decades of space exposure, carrying the hopes of mankind as it ventured boldly where no one had gone before. Dr. Stone's decade-long stewardship ensured the mission's remarkable longevity, setting the stage for an unprecedented exploration of our solar system. Built with 1970s technology that would seem primitive by today's standards, Voyager 1 was nevertheless equipped with instruments sensitive enough to detect the faintest signals from the cosmos. The spacecraft's nuclear power source, designed to last far beyond its primary mission, would prove crucial for its extended journey into the unknown. This remarkable engineering feat would soon carry humanity's message to the stars and beyond. The Grand Tour. Voyager 1's Grand Tour of the solar system became legendary, lasting over 12 years and bringing humanity close to the gas giants Jupiter, Saturn, Uranus, and Neptune. During flybys, it sent back unparalleled images and life-changing data that redefined our understanding of these colossal planets. Notably, the encounter with Jupiter revealed the planet's turbulent atmosphere and intense magnetic field, reshaping planetary science forever. The spacecraft discovered active volcanoes on Jupiter's moon Io and revealed the complex structure of Saturn's rings in unprecedented detail. Subsequent visits to the outer planets expanded our knowledge of ice giants and their mysterious moon systems. Each planetary encounter used gravitational assist to propel Voyager faster toward the edge of the solar system, a trajectory carefully calculated to maximize scientific return. The spacecraft's cameras captured images that became iconic symbols of human exploration, including the famous pale blue dot photograph of Earth taken from 4 billion miles away. Voyager's trajectory, programmed for a final sprint beyond the solar system, demonstrated NASA's engineering brilliance in interplanetary travel. Today, its legacy continues as it ventures into interstellar space, humanity's first emissary beyond the protective bubble of our sun's influence. The Golden Record. The Golden Record aboard Voyager 1 is a time capsule destined to outlast humanity itself, containing sounds and images representing Earth's diversity. Curated by Dr. Carl Sagan and a committee of scientists and artists, the record includes greetings in 55 languages and music spanning cultures and epochs. Encased in an engraved gold-plated copper disc, it serves as a cosmic message in a bottle, intended for any intelligent life that may encounter it in the distant future. The record also contains scientific information about Earth's location, using pulsar maps devised by Dr. Frank Drake, providing a cosmic roadmap for potential discoverers. Despite its age, the Golden Record remains a testament to human curiosity and hope across the void of space, symbolizing peace and universality. The record includes sounds of Earth, from ocean waves to human heartbeats, from classical music to the laughter of children. It represents humanity at its best, showcasing our diversity while emphasizing our common bonds. Voyager's legacy is as much cultural as scientific, immortalizing humanity beyond our solar system boundaries. This golden message continues its journey through the cosmos, carrying our hopes and dreams to destinations unknown. Years in the void. Years of drifting through the cold void beyond our solar system, Voyager 1 has defied all expectations for spacecraft longevity. Since crossing the heliopause in 2012, it has continuously sent back data about interstellar space despite operating far beyond its design limits. Engineers at NASA Jet Propulsion Laboratory, led by Dr. Suzanne Dodd, have managed to keep the spacecraft operational despite dwindling power supplies and aging components. Voyager's instruments continue to measure the harsh radiation environment far beyond any planet's protective magnetosphere, revealing a cosmos more dangerous and dynamic than anyone imagined. The spacecraft's telemetry reveals vital signs including temperature readings and electrical system status, a testament to the incredible engineering resilience of 1970s technology still performing flawlessly in the most hostile environment known. Each year, Voyager's plutonium power source weakens, forcing mission controllers to make difficult decisions about which instruments to shut down to conserve energy. Yet the spacecraft persists, transmitting scientific data across billions of miles of empty space. Voyager 1's longevity contrasts sharply with initial mission expectations, with scientists noting it has become humanity's longest-lived emissary in the cosmos, far exceeding all predicted operational timelines. Crossing the boundary. Voyager 1's historic crossing of the heliopause marked humanity's first journey into true interstellar space, a milestone that redefined our understanding of the cosmic frontier. The spacecraft's instruments, including sophisticated sensors and detection equipment, began recording phenomena unlike anything seen within our solar system's protective bubble. Lead scientist Dr. George Glockler from the University of Minnesota explains the significance of these observations, revealing magnetic field turbulence and unexpected plasma oscillations that challenge existing models of the interstellar medium. The boundary between solar and galactic space proved far more complex and dynamic than theoretical predictions suggested, showing multiple layers and transitional zones rather than a clean separation. Voyager's data revealed that interstellar space is not the quiet, empty void scientists once imagined, but rather a region filled with electromagnetic activity and cosmic phenomena. The spacecraft detected charged particles moving at incredible velocities, evidence of ancient stellar explosions and cosmic events that occurred millions of years ago. These measurements provided the first direct sampling of materials from beyond our solar system, offering insights into the composition and behavior of the galaxy itself. Voyager's continuing transmission from this unexplored realm offers unprecedented insights into the boundary between solar influence and the vast galactic ocean beyond our protective heliosphere. Signals from nowhere. In late 2023, Voyager 1 went mysteriously silent, sparking fears among mission scientists who had dedicated decades to the project. Analysis revealed a corrupted memory chip, likely damaged by a high-energy cosmic ray that struck the spacecraft with devastating precision. Immediate action by the Jet Propulsion Laboratory team, including Flight Director Dr. Melissa Brown, involved rerouting computer operations to back up memory areas while working across an impossible distance. This delicate software workaround, performed from Earth with signals taking over 22 hours each way, required extraordinary precision and patience from the engineering team. The rescue operation demonstrated incredible human ingenuity, essentially performing remote brain surgery on a patient billions of miles away using technology older than most of the engineers working on it. When Voyager finally responded, it brought relief to scientists worldwide who had feared losing humanity's most distant explorer forever. The incident highlighted both the spacecraft's vulnerability and resilience, showing how a single cosmic particle could threaten decades of scientific discovery. The successful restoration of communication proved that even in the depths of interstellar space, human determination and technical expertise could overcome seemingly impossible odds and continue our journey of cosmic exploration. The temperature mystery. Voyager's instruments have detected bizarre temperature anomalies in the interstellar medium that defy current scientific understanding of cosmic thermodynamics. The spacecraft's sensors recorded unexpected heat signatures and thermal variations that suggest unknown energy sources operating in supposedly empty space. Dr. Reka Winslow from the University of Michigan analyzed data showing these temperature fluctuations correlate with mysterious electromagnetic activity that creates complex thermal gradients across vast distances. These findings indicate dynamic processes previously unknown to science, with energy transfers occurring through mechanisms that current physics cannot fully explain. The spacecraft's thermal sensors detected variations that challenge existing models of interstellar space, revealing an environment far more active and energetically complex than anticipated. These thermal anomalies persist across the spacecraft's trajectory, creating a puzzle that has scientists scrambling to develop new theories about energy distribution in interstellar space. The temperature readings suggest that the void between stars may harbor energy sources or phenomena that could revolutionize our understanding of cosmic physics. Some researchers speculate these thermal signatures could indicate the presence of dark matter interactions or unknown electromagnetic processes that operate on galactic scales, opening entirely new avenues for astrophysical research and discovery. Changing course. Maintaining control over a spacecraft traveling through the depths of interstellar space requires unprecedented precision in navigation techniques and trajectory management. Dr. Carlos Hernandez from NASA Goddard Space Flight Center leads efforts to execute delicate course corrections on Voyager 1, despite the enormous challenges posed by distance and communication delays. These trajectory adjustments must account for the spacecraft's changing orientation, limited fuel reserves, and the gradual degradation of its attitude control systems after decades of operation. The complex calculations required for each maneuver consider gravitational influences from distant stars, the pressure of interstellar particles, and the spacecraft's slowly declining power output. These adjustments demonstrate unparalleled precision in space navigation, requiring engineers to predict and compensate for factors that won't be observable for hours due to signal travel time. Each course correction represents a carefully calculated gamble, as there are no second chances when working with such precious and irreplaceable scientific assets. The navigation team must balance scientific objectives with spacecraft preservation, making difficult decisions about energy expenditure and pointing accuracy. Despite these challenges, Voyager continues to maintain its scientific mission while heading toward an eventual encounter with the star AC plus 79 3888 in approximately 40,000 years. Ghost in the machine. Recent months have seen Voyager 1's onboard computer systems exhibit mysterious glitches that have puzzled mission engineers and raised concerns about artificial intelligence anomalies. Led by Dr. Ananya Singh at NASA's Jet Propulsion Laboratory, the team closely monitors these strange behaviors manifesting as unexplained error codes and signal irregularities that don't match any known failure modes. The anomalies appear almost intelligent in nature, as if something within the spacecraft's systems is learning and adapting to its environment in ways the original programmers never intended. Some engineers speculate these phenomena arise from cosmic radiation effects interacting with the spacecraft's aging electronics in unexpected ways, while others wonder if decades of exposure to interstellar conditions have somehow altered the computer's fundamental operations. The spacecraft occasionally transmits data patterns that seem to contain information beyond its programmed capabilities, leading to speculation about whether the harsh environment of space might be inducing evolutionary changes in electronic systems. Diligent troubleshooting and software updates aim to preserve communication integrity, but the mysterious behaviors continue to manifest despite all efforts to understand or control them. These electronic anomalies represent one of the most puzzling aspects of Voyager's extended mission. Patterns within patterns. Recent analysis of Voyager's long-term data has revealed subtle but persistent patterns in cosmic ray measurements and magnetic field variations that suggest influences from unknown astrophysical sources. Dr. Emilia Garza, a heliophysics expert from the University of Texas, notes the discovery of quasi-periodic oscillations that appear to originate from deep space phenomena beyond our current understanding. These patterns within patterns challenge assumptions about the uniformity of interstellar space, instead revealing a complex structure operating on multiple scales and timescales that scientists are only beginning to comprehend. The oscillations show characteristics that don't match any known natural phenomena, leading some researchers to speculate about possible artificial origins or previously unknown physical processes occurring in the galactic environment. Voyager's instruments detect synchronizations and correlations in the data that seem too organized to be purely random, suggesting underlying mechanisms that organize matter and energy across vast cosmic distances. These discoveries have profound implications for our understanding of how the galaxy operates, potentially revealing hidden structures or forces that influence the behavior of matter and energy throughout interstellar space. The patterns continue to evolve as Voyager travels deeper into unexplored regions, providing humanity with its first glimpse into the true architecture of our galactic neighborhood and the mysterious forces that shape it. Voyager 1 continues its impossible journey into the cosmic unknown, revealing mysteries that challenge our understanding of the universe itself. From strange temperature anomalies to unexplained computer behaviors, this tiny spacecraft has encountered phenomena that suggest the cosmos holds secrets far beyond our current knowledge. As it drifts ever deeper into interstellar space, Voyager carries not just our scientific instruments, but our hopes and fears about what lies beyond our protective solar bubble. Subscribe to Stellar Tech for more revelations about humanity's greatest adventure and the discoveries that await us in the darkness between the stars. What if the most profound discovery in human history was made, and then deliberately buried? We're not talking about rumors or grainy photos here. We're talking about 24 gigabytes of classified NASA data on an interstellar visitor that, well, defied the laws of physics. Data leaked by a ghost-like hacker group revealing a 26-kilometer-wide object that wasn't just passing through our solar system but was actually, actively navigating it. This is the story of 3I Atlas, what NASA allegedly found and why they never wanted you to see it. Let's delve into the data. Event Horizon cyber attack. So how does a clandestine group get its hands on NASA's crown jewels? According to the leaked security logs, this wasn't a brute force attack, it was surgical. In the early hours of September 2, 2025, Event Horizon executed a coordinated cyber attack that bypassed multiple layers of agency firewalls. They exploited a zero-day vulnerability in an outdated Fortran-based mission planning module, a tiny crack in an otherwise formidable digital fortress. The transfer rate was a blistering 571 megabits per second, far too fast for automated security flags to catch in time. Forensic analysts later pieced together a chilling timeline. The attackers gained initial access at 3:14 a.m. Eastern, escalated their privileges to the highest level by 3:19, and began siphoning data at 3:23. In under 7 minutes, 24 gigabytes of compressed files, including internal chat logs, draft reports, and sensitive telemetry from the 3I Atlas intercept mission, were gone. By 3:30 a.m., the connection vanished, leaving behind nothing but a silent gap in the audit trail. Cybersecurity expert Mikko Hipponen has stated that such an attack would require nation-state level resources, suggesting Event Horizon is far more sophisticated than a typical hacktivist group. The manifesto and distribution. A data breach is one thing, but a declaration of war on secrecy is another. Within hours of the hack, a manifesto from Event Horizon appeared on encrypted forums. Their message wasn't a boast, it was a justification. They claimed the breach was a direct response to what they termed unlawful cosmic secrecy, arguing that discoveries of this magnitude belong to humanity, not to a select few government agencies. The manifesto warned that the stolen files contained information so sensitive even senior directors at NASA were allegedly unaware of its full scope. Their language was direct: the world deserves to know what its own scientists have found. To prove their point, they began a strategic distribution campaign. Blurred screenshots and heavily redacted memos were sent to journalists and channels known for covering classified science. They specifically avoided mainstream outlets, opting for platforms that would analyze the data without an institutional filter. This drip feed of information created a groundswell of speculation that legacy media couldn't ignore, forcing the conversation into the open on Event Horizon's terms. Authenticating the documents. In the world of leaks, authenticity is paramount, so are these files real? The evidence presented by Event Horizon is compellingly layered. The leaked screenshots are plastered with authentic details: bold, block-lettered confidential stamps, thick redaction blocks, and metadata tags showing UTC timestamps that perfectly match the breach window from NASA's own security audit. We see mission patch artwork in the corners, a stylized comet labeled 3I Atlas Int. Every document carries unique identifiers, routing codes, and internal chat handles you'd expect to see inside a major agency. Technical diagrams and draft tables use Courier font headers and bear NASA's internal digital watermark. We even see screenshots of the classic blue and white NASA email interface, with subject lines like Atlas Intercept Immediate Action Required, and Telemetry Review Anomaly Detected. One partially blurred memo lists technical trajectory data, while another redacted report is marked with the access level TSSCI, denoting top secret sensitive compartmented information, a classification that restricts access to a small, specific group of cleared individuals. The documents bear digital signature strings ending in JPL for the Jet Propulsion Laboratory, and GSFC for the Goddard Space Flight Center, indicating a multi-center collaboration. Discovery of 3I Atlas. Before the leak, there was the discovery that started it all. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey in Hawaii, logged a new object tearing into the solar system at 130,000 miles per hour. Astronomers flagged it immediately. This was no ordinary comet. The object, soon labeled 3Y Atlas, measured an estimated 26 kilometers across, roughly the size of Manhattan. moving faster than any object ever observed inside the orbit of Jupiter. Veteran survey scientist Dr. Lina Takahashi, a fictional name from the leaked files, was quoted in a log. The track was so steep, the software flagged it as an error. Within hours, observatories from Chile to Arizona confirmed the numbers. The object's incoming speed of over 58 kilometers per second defied the sun's gravitational grip. Its trajectory pointed back toward the constellation Lyra, far from the ecliptic plane where most solar system debris resides. To put its size in perspective, the asteroid that killed the dinosaurs was only about 10 kilometers wide. This was over twice that, and it wasn't from around here. Impossible physics and trajectory. Here's where the story takes a sharp turn from unusual to unbelievable. Like its predecessor Oumuamua, 3I Atlas was not behaving according to the laws of physics. The leaked mission logs from July 18, 2025, show a sudden, inexplicable sideways acceleration resulting in a velocity change, or delta V, of 1.5 meters per second. The object changed course in a way that defied gravitational models. For a normal comet, such a deviation could be explained by outgassing, measured by the non-gravitational acceleration parameter, A2. However, just like with Oumuamua, initial observations of 3I Atlas showed no cometary tail, no dust and no gas coma to account for the push. Its A2 parameter was effectively zero, yet it was still maneuvering. Trajectory analysts were stumped. They ran models accounting for solar radiation pressure, gravitational pulls from planets, and every known natural force. Nothing matched the telemetry. Dr. Amy Mainzer, a leading expert on asteroids, has noted that explaining such a deviation without observable outgassing requires exotic physics or an artificial origin. The numbers kept pointing to a single, unsettling conclusion. Some force other than gravity was steering this massive object through our solar system. Surface anomalies, the armor problem. What does a 26-kilometer object from another star system look like? The first leaked images from the Intercept mission were paradigm-shattering. 3I Atlas's surface resembled no comet on file. Imaging analysts flagged a pattern of smooth, almost metallic-looking plating, broken by lines that ran too straight to be natural fractures. One analyst, quoted in a redacted chat log, called it the radiator problem, referring to a gridwork of raised ridges spaced like the cooling fins on spacecraft. These ribs cast long, uniform shadows, and their regularity caused the anomaly detection software to flag the pattern as artificial. Comparisons to known comets like Halley or 67P Churyumov-Gerasimenko fell apart. Their surfaces are jagged and chaotic. 3I Atlas, in contrast, had long stretches that reflected sunlight like polished alloy. Further spectral analysis of this reflected light showed an albedo inconsistent with any known meteoritic iron, lacking the usual chondritic features. It was too smooth, too reflective, and far too structured. Thermal signatures and heat pulses. If the surface looked engineered, the thermal data was even more alarming. According to the leaked files, infrared arrays recorded heat vents pulsing with incredible regularity. The logs show heat pooling along the strange ribbed seams and then bursting outward in tight, directed jets. This wasn't the broad, chaotic outgassing you see in a typical comet. These were discrete, timed pulses occurring precisely every 90 seconds, raising local surface temperatures by over 200 degrees Kelvin in an instant. The mission logs classified this as a directive motion event, a term typically reserved for spacecraft thrusters, not natural phenomena. Even more damning, trajectory analysts correlated these thermal pulses directly with the object's mysterious course corrections. After each 90-second heat burst, the Intercept team logged a subtle but precise shift in its path. The efficiency of this propulsion, measured as specific impulse, was calculated to be far beyond any chemical rocket, consistent with advanced ion or plasma thrusters. Gravity couldn't explain it, solar radiation is constant, and natural outgassing is random. The evidence was building 3I Atlas wasn't just moving strangely, it appeared to be actively propelling itself. Chemical composition mysteries. The mystery only deepens when you look at what 3I Atlas was made of. Martin Cordner's team at Goddard was the first to get a full spectrum after the Intercept, and the results were an instant red flag. The early spectra lit up with incredibly sharp, bright lines of nickel. In cosmic bodies, nickel almost always rides shotgun with iron. Yet in every single frame of data from 3I Atlas, iron was almost completely absent. Its signature spectral lines were missing. This isn't just rare. In the entire catalog of known comets and asteroids, it's unheard of. The natural formation processes that create asteroids from protoplanetary disks simply don't separate these two elements with such purity. Leaked notes suggest the isotopic ratio of the nickel was also wrong, indicating it wasn't formed in a typical supernova. The purity level was estimated to be over 99.8%, a level that on Earth requires an advanced electrochemical process known as the MOND process. Radio echoes and communication patterns. Beyond its motion and materials, the most chilling evidence in the leaked files points toward active technology. According to the logs, radio astronomers reviewing raw data from the Intercept mission flagged a pattern of faint, repeating echoes in the X-band frequency range. These weren't natural radio bursts or cosmic static, they were precise, clipped signals with a high signal-to-noise ratio, bouncing back from 3I Atlas at regular intervals. What made this truly shocking was the timing. The interval of the radio echoes mapped almost perfectly to the 90-second rhythm of the object's thermal pulses. It was as if something was pinging the object, and the heat pulses were the response. In one of the leaked chat logs, a veteran telemetry specialist reportedly wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." This completely changed the nature of the investigation. SETI pioneer Dr. Jill Tarter has long argued that a truly intelligent signal would likely be efficient and information-dense, characteristics that align with these alleged repeating echoes. The data suggested it could be an active, responsive probe. Expert analysis and propulsion theory. You can't discuss these anomalies without bringing in a voice of scientific courage like Avi Loeb. The Harvard astrophysicist, who famously staked his reputation on Oumuamua being alien technology, wasted no time weighing in on the 3I Atlas files. He argued the intercepted telemetry read like a blueprint for an advanced propulsion system. Each 90-second heat pulse and corresponding course correction was perfectly consistent with a massive ion drive or a similar engine. In Loeb's words, if you wanted to navigate through a solar system while managing heat and energy, you would use timed, directional thrust. That is what the data shows. But the most jarring evidence was a fragment recovered by the interceptor's dust collector. A leaked lab memo described a fleck of material with a lattice of silicon and doped phosphorus, arranged in layers spaced at micron intervals. The structure was noted as being radiation-hardened to a degree far beyond current human capability, suggesting it was built for long-duration travel through the harsh interstellar medium. This wasn't just a circuit, it was an artifact from a civilization far beyond our own. So what do we make of all this? A 26-kilometer object from another star system, moving at impossible speeds, making its own course corrections. It has a surface that looks like armor, a composition of refined nickel, and it pulses with heat and radio echoes on a perfect 90-second clock. And finally, there's a fragment of what appears to be a microchip. The leaked files, if authentic, present a disturbing and profound reality. The questions are staggering. What is this object's purpose? Where did it come from? And perhaps most importantly, what else has NASA found that we don't know about? Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching Stellar Tech. Right now, 15 billion miles from Earth, humanity's most distant messenger is revealing secrets that are, honestly, rewriting our understanding of space. Voyager 1 crossed into interstellar space back in 2012, becoming the first human-made object to leave our solar system's protective bubble. But after a terrifying communication blackout in 2023, the spacecraft came back online with data that absolutely stunned scientists. The space between stars isn't the empty void we imagined, it's actually a dynamic, structured environment filled with cosmic weather, invisible boundaries, and phenomena that challenge everything we thought we knew about our galaxy. The Silent Crisis. April 2024 brought relief after months of cosmic terror. Voyager 1 had gone completely silent, transmitting only garbled signals that made no sense to NASA engineers at the Jet Propulsion Laboratory. After 46 years of faithful service, humanity's most distant explorer was dying. The culprit was a corrupted memory chip, likely damaged by a cosmic ray strike. The very phenomenon Voyager was studying had wounded it. Engineers faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away, where radio signals take over 22 hours for a round trip. The rescue operation required rerouting code into backup memory areas, essentially giving CPR to a robot that predated most modern computers. By May 2024, the patient showed signs of life, with all 4 science instruments gradually coming back online. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system.
Magnetic mysteries beyond the edge.
The first shock came from Voyager's magnetometer readings after crossing the heliopause. Scientists expected some differences, but the interstellar magnetic field showed a dramatic misalignment compared to our sun's magnetic influence. This wasn't a gradual transition, it was a sharp boundary suggesting something far more significant than anyone had anticipated. The readings point to Voyager 1 entering a magnetic turbulence zone where galactic magnetic fields twist and reconnect in ways that could, honestly, reshape our understanding of galactic structure. These aren't small ripples in space, they're fundamental forces operating on scales larger than our entire solar system. The magnetic field orientations Voyager measures might even channel cosmic material into denser regions, potentially influencing where new stars form in our region of the galaxy. Each measurement reveals that interstellar space has its own magnetic weather patterns, invisible highways of force that guide particles across vast cosmic distances. The spacecraft continues to detect these magnetic anomalies, proving that the space between stars is far more structured and dynamic than anyone predicted. The cosmic ray avalanche. Crossing into interstellar space triggered an immediate and honestly shocking discovery. Voyager's cosmic ray detector recorded a sharp spike in high-energy particles accelerated to nearly light speed by distant supernovae and black holes. The increase wasn't gradual, it was abrupt, like stepping through an invisible barrier. This revelation exposed how effectively our sun's heliosphere shields Earth from the harsh radiation environment of interstellar space. We're living in a cosmic oasis, protected from particle bombardment that would be lethal to unshielded life. But the pattern isn't uniform. Voyager has detected systematic variations, suggesting natural radiation corridors, cosmic highways where particles preferentially flow. These measurements hint at larger galactic structures, possibly ancient scars left by stellar explosions that shaped our neighborhood millions of years ago. The spacecraft may be detecting pressure gradients that map onto invisible architecture spanning light years. Each cosmic ray measurement reveals more about the galactic environment, showing that we're not just measuring local conditions, but glimpsing the aftermath of cataclysmic events that continue to influence our cosmic neighborhood today.
Whispers in the void.
You know, the silence of space doesn't actually exist. Voyager's plasma wave instrument has completely shattered the old myth of cosmic emptiness by detecting these constant low-frequency oscillations that just permeate interstellar space. And these aren't just random fluctuations, no, they're structured signals, suggesting that the space between stars has its own unique acoustic signature. The instrument has even picked up multiple plasma density spikes, kind of like pressure waves moving through an invisible medium out there. Scientists think these could be shock fronts left behind by ancient supernovae that exploded thousands of years ago, still rippling through the interstellar medium today. So Voyager isn't just drifting through emptiness, it's flying through an invisible fog with its own distinct layers and properties. Some regions are hotter, others are denser, and together they create this complex three-dimensional structure that actually resembles weather patterns a lot more than the uniform void scientists once expected. This cosmic hum, it's really the background activity of our galaxy, a constant whisper from the space between stars. The plasma waves are revealing that interstellar space has its own dynamics, its own currents and temperatures, creating an environment that's far more active than anyone could have imagined.
Interstellar weather patterns.
Voyager 1 has actually passed through at least 2 distinct interstellar cloudlets since crossing the boundary, and this has revealed that the space between stars has structure, kind of like an ocean with currents and eddies. These aren't visible clouds though, they're regions where the plasma, dust, and gas density suddenly changes by factors of 2 or even 3 times. The spacecraft's instruments show evidence of these structured plasma ripples with clear boundaries, almost like atmospheric fronts out in space. NASA scientists now believe our sun is moving through the local interstellar cloud, and Voyager is helping to define its outer edges right now. This cloud exists inside the much larger local bubble, which is this enormous cavity created by ancient supernovae. These density shifts, they actually affect Earth's cosmic ray exposure over millennia. As our solar system drifts through different interstellar environments at 450,000 miles per hour, the radiation environment at Earth subtly changes, and that can potentially affect cloud formation and even mutation rates in living organisms. Voyager is showing us that interstellar space isn't just a straight path. It's really a gauntlet of invisible forces that create this complex, ever-changing cosmic landscape, complete with its own weather systems and boundaries.
Digital resurrection.
So, the 2023 communication crisis nearly ended humanity's only direct window into interstellar space. For months, Voyager 1 was transmitting incomprehensible data, its memory corrupted by cosmic ray bombardment. NASA engineers were suddenly facing one of their greatest challenges: remotely repairing a spacecraft that's actually older than most of their careers, and doing it with technology from the Carter administration no less. The solution took unprecedented ingenuity, rerouting decades-old code into backup memory areas while somehow maintaining all the critical functions across a 15 billion-mile gap. And every command took 22 hours to reach the spacecraft, so real-time troubleshooting was just impossible. The team basically performed remote surgery on a patient they couldn't see or touch. In April 2024, they finally had a breakthrough when basic telemetry resumed, and that was followed by the gradual revival of the scientific instruments. By June 2024, all 4 active science instruments were functioning again. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system's protective bubble. The rescue operation showed that even 1970s technology could be revived through innovative engineering, buying us precious additional years of interstellar data collection.
Mapping the invisible galaxy.
Voyager 1 is creating something, well, truly unprecedented, a navigational chart of interstellar space. With every data packet sent back, scientists are able to construct 3-dimensional models of the Milky Way's magnetic and radiation zones, using Voyager's measurements as crucial anchor points. This, honestly, represents the first real-scale cartography of our stellar neighborhood. It's a bit like having a weather satellite, but for the cosmos. The cosmic ray gradients, particle density readings, and magnetic field orientations are revealing natural shields and danger zones, and these could really determine whether humans can safely venture beyond our solar system. The radiation environment that Voyager measures is far more intense than what astronauts face in Earth orbit, which makes these maps absolutely crucial for any future interstellar missions. Some astrophysicists even believe the structures Voyager is mapping may influence star formation patterns across our galactic region. Quietly, the spacecraft is drawing the first blueprint of the space between stars, creating detailed models that get refined with every new measurement. This mapping project has, well, become the foundation for understanding how to navigate the void between stars, potentially guiding future spacecraft through the safest corridors of interstellar space.
The protected oasis.
Voyager's measurements have revealed a profound truth about Earth's place in the cosmos. Our solar system exists within a protective bubble that shields us from an environment far more hostile than anyone realized. The dramatic increase in cosmic radiation beyond the heliopause demonstrates how effectively the sun's magnetic field deflects dangerous particles that would otherwise bombard our planet. This discovery reframes Earth not just as our home, but as our shelter in a cosmic storm. The interstellar medium contains radiation levels that would pose serious threats to unprotected life, making our heliosphere a crucial barrier against galactic hazards. Voyager's data shows that this protection varies as our solar system moves through different interstellar environments over millions of years. The spacecraft's measurements of density variations and magnetic field changes suggest our cosmic neighborhood is far from uniform. We're traveling through a complex landscape of radiation zones, magnetic boundaries, and plasma clouds that create an ever-changing environment around our solar system. Understanding these variations helps explain long-term climate patterns and cosmic ray exposure cycles that may have influenced life's evolution on Earth.
The eternal journey.
Beyond its scientific mission, Voyager 1 carries humanity's most enduring message to the cosmos. The golden record attached to the spacecraft contains sounds, music, greetings in 55 languages, and 116 images representing Earth's diversity. This time capsule is engineered for extreme longevity, designed to survive over 1 billion years in the harsh environment of space. In approximately 40,000 years, Voyager 1 will make its closest approach to the star Gliese 445, passing within 1.6 light-years of this distant red dwarf. long after Earth's continents have shifted beyond recognition, long after human civilization has evolved or disappeared, this record will endure. Voyager represents humanity's most lasting trace in the universe, an ambassador that will outlive our species. No other human object will leave the heliosphere for decades, making Voyager literally our longest-lasting monument. The spacecraft transforms from a scientific probe into something more profound, a message frozen in time, carrying the essence of who we were in 1977 across the galaxy for eons to come. This cosmic time capsule gives Voyager significance that transcends its scientific achievements, becoming humanity's first tentative step into eternity.
Redefining reality.
The space beyond our solar system isn't the featureless void astronomers once imagined. Voyager 1 has revealed a dynamic structured environment with weather patterns, magnetic topography, and radiation zones that shape our galaxy's invisible architecture. The transition from our solar bubble to interstellar space isn't clean. It's messy, complex, and honestly pretty fascinating. Magnetic fields don't align as expected, radiation environments change dramatically, and plasma waves suggest constant activity we never knew existed. Voyager's discoveries prove that interstellar space has layers, fronts, and boundaries, creating a textured cosmic landscape far more intricate than anyone predicted. The spacecraft continues operating on borrowed time, with NASA making difficult decisions about which instruments to shut down as power gradually fades. Early 2025 saw the cosmic ray detector powered down to extend the overall mission, but 3 science instruments continue transmitting their faint 23-watt signals across the cosmic void. Each day Voyager 1 operates as a gift of knowledge from humanity's only direct sampling of the space between stars, rewriting textbooks with every transmission from the interstellar frontier. Voyager 1 reached the other side, and the reality is more extraordinary than fiction. The interstellar medium isn't empty. It's a structured, dynamic environment that challenges our understanding of cosmic architecture. From magnetic mysteries to plasma whispers, from radiation avalanches to cosmic weather patterns, Voyager continues revealing secrets that rewrite astronomy textbooks. This incredible journey proves that sometimes the most profound discoveries come from the simplest act of reaching beyond our boundaries. If you love real space exploration without the hype, smash that like button and subscribe to Stellar Tech for more mind-blowing cosmic discoveries. The universe is far stranger than we thought.